There are only two industries that refer to their customers as users. It's illegal drugs and software. Edward Tufte, a quote from Edward Tufte. Now, why are we so fascinated with software? Why are we considered users, maybe even addicted to software and technology? Well, maybe it's because what Arthur C. Clarke said when he quoted, "Any sufficiently advanced technology is indistinguishable from magic." One of my favorite quotes, and it's true. We see new technology and we're amazed. I can remember when spell checker came out, I was absolutely amazed that technology could spell check words. And now that is so basic. And we look at what we have today with artificial intelligence and robots and machine learning and augmented and virtual reality, and we're dazzled by all of this. It's like magic. And we become addicted to these technologies and we want more. But it raises the question, are advanced technologies taking over the world? And is it safe for algorithms to make decisions for us? Well, these answers are pretty much, are technologies taking over the world? Yes. Are these algorithms safe to make decisions for us? Well, they already are making decisions for us. Now, safety as far as are they making the right decision, that is dependent upon who programmed them, who's monitoring them and checking them. But the problem we face is that technology outpaces ethics. So there's always this constant battle of balancing ethics with technology to rein it in. In general, science advances so fast it can outpace ethics, and so ethics needs to bring science back to, well, an ethical sense. So let's go ahead and begin our second episode of the Quality Culture Podcast. And in this episode, we're going to be talking about the fourth industrial revolution. Things are changing, especially in life sciences, and even the FDA recognizes this. In September 22nd of 2020, FDA launched the Digital Health Center of Excellence. And let me go ahead and read this press release to you, or this FDA release, because I think it's fascinating that even the regulatory board here recognizes the importance of digital health technology, etc. So today, the U.S. Food and Drug Administration announced it's launching the Digital Center of Excellence, the Digital Health Center of Excellence. With the Center for Devices and Radiological Health, CDRA, the launch of the Digital Health Center of Excellence is an important step in furthering the agency's overarching, that was a Freudian slip, agency's overarching dedication to the advancement of digital health technology, including mobile health devices, software as a medical device, or SAMD, wearables when used as a medical device, and technologies used to study medical products. And establishing the Digital Health Center of Excellence is part of FDA's work to ensure the most cutting-edge digital health technologies are rapidly developed and reviewed in the U.S. So we can see that they recognize the importance of digital health. The advancements can be beneficial and actually bring life-saving things to people in need. So even the regulators understand the importance of technology. And we understand the technology that we have today, or we're learning the technology we have today. If we look at the technology not too far back, then we think it's pretty basic. Let's talk about the old games, the video games that we had. Pong, for example, was fascinating. It was like magic when it first came out. And now we look back at it, and it's pretty basic. It's still amazing. It's a novelty, and it's fun, but it's pretty non-sophisticated as compared to what we see right now with virtual reality. So the technology we have today is pretty clear, and we're learning more. And what will happen in the future is a little bit gray. It's unknown. As for our future, it's unknown to us right now. And as we march through time, our future will become clear because it will become the present. But then the technology is going to become more gray. So we have this constant battle of technology in the future. Is it black and white? Is it gray? It's always evolving and pretty much impossible to keep up with. But hopefully we can shed some light on that today, insight, and encourage you to dive a little bit more deeply into these areas that we're talking about. So let's talk about the technology, then we'll talk about the future. Industry 4.0, what is it? Well, you've probably heard it mentioned as the factory of the future. And then in life sciences, we specifically refer to it as Pharma 4.0. And it's exciting because we are living in the middle of the fourth industrial revolution. We are in the middle of an industrial revolution. And to understand this, let's take a look at what the prior three industrial revolutions were. Back in the 18th century, it was steam. The steam engine was like magic, and it could power locomotives. Before, it was horses and buggies, and you were kind of limited on your travel. Now you've got a steam engine train that can take us further than we've ever gone before, and we have factories that can be steam-powered and do more than we've ever done before. That was the 18th century. Then came electricity in the 20th century, and that changed everything. Everything was electrified, and we were able to have lights, and it really changed the world. Then we get into the 1970s. The third industrial revolution was robotic, and we saw robots appearing, manufacturing lines, etc. And now we're in the fourth industrial revolution. So what is it? It's cyberphysical. The fourth industrial revolution is cyberphysical. It's the cyber world working with the physical world, and you'll see what that is as we dive into it a little bit more deeply. Let's take a quick trip along the factory of the future realm and intelligent automation. And the Boston Consulting Group talked about the factory of the future and really broke it down into three key areas, three dimensions. And in our industry, life sciences, I add the fourth dimension, which is quality. But basically, the factory of the future, according to Boston Consulting Group, is a vision for how manufacturers should enhance production by making improvements in these three dimensions: structure, digitization, and processes. When it comes to structure, there's fascinating things that can happen. Omnidirectional autonomous transport, reconfigurable modular lines, sustainable green production. Let's talk about the omnidirectional autonomous transport. What is it? Well, we could have conveyor belts that move things along a serial linear line, but with omnidirectional autonomous transport, which is real, it's happening, these robots carry things like car bodies around, guided by lasers on the manufacturing floor to where they need to go to next. In order to reconfigure the direction, we don't have to disassemble a conveyor belt and reassemble it some other way. You simply just reprogram or redirect the lasers, and then you can change the direction. It's omnidirectional, can go in any different direction. That's just an example. And then with reconfigurable modular lines, it's kind of like Legos. We can design our factory of the future where we can have reconfigurability to scale up, scale down, change our manufacturing lines, etc. Then we get into the second dimension, which is digitization. And here, again, the Factory of the Future article by the Boston Consulting Group talks about robots, robotic process automation, additive manufacturing, which is 3D printing, augmented reality, 3D simulations, autonomous production processes, big data analytics. When you think of robots, we'll get to that in a minute, it's more than just the physical robots. Robots can also be software, and robotic process automation is a very promising technology. It's here today, and it can actually process those tedious, mundane tasks that humans may have done in the past, but the robotic process automation can handle that. It's a routine transaction, known what to do, and it just carries out those tasks that need to be performed by software robots. And robots can even hack systems, and it's very methodical. They're robots that just continually try things over and over to hack systems. So you can hear bots or bot attacks, or those are basically robots. And they're cyber, they're software. They're not physical robots, but there are physical robots as well. Then when it comes to additive manufacturing, we can see that parts are being made, prosthetic devices are being made for people that are missing limbs, as an example. And you can do all kinds of things with additive manufacturing. There's even speculation that with 3D printing, if we could print on a nanoscale and we can have active ingredients in an ink, then could we potentially print out pharmaceuticals, print out the molecular structure, add the active ingredient as an ink, and then is that possible? I don't know. People are actually exploring that idea. Augmented reality, you could be somewhere and not physically be there. You could be looking at things, as an example. For virtual reality, you could be virtually anywhere and not physically be there in a virtual world. But with augmented reality, I could be somewhere and I can have the reality augmented, overlaid on top of it, to where I am looking out at a physical, real world, and I have a digital world superimposed in front of my eyes on something that may be like a fighter cockpit plane, where you have a screen up in front, and that image floats in front, so you can see all different types of things, like indicators, altitude, or even guiding missiles and stuff like that. So you could augment reality with technology. And then with 3D simulations, you can do all kinds of things. What if we changed the production floor? So those are just some of the examples on the second dimension. And then when it comes to big data and analytics, if you look at the growth of data, it's just staggering how much data we're generating. And there's a comparison with ResearchGate.net back in 2009, looking at the number of exabytes, and they were looking at around less than 1,000 exabytes, and then fast forward to 2020, it's approaching 7,000 exabytes of information. And what is an exabyte? Well, it's 8.98 e to the 20 bytes. It's 6.6 zettabytes. And if you want to know what a zettabyte is, it's 1 billion terabytes. So 1,000 gigabytes is 1 terabyte, 1,000 terabytes is 1 petabyte, 1,000,000 terabytes is an exabyte, and then 1 billion terabytes is a zettabyte. So humanity has passed the 1 zettabyte mark in 2010. We passed the 1 zettabyte mark in 2010, meaning in 2010, we went beyond 1 billion terabytes. The amount of information is overwhelming, and the only way to analyze that information, it's impossible for human beings to do it, and that's where in the second dimension of the Boston Consulting Group's digitization phase, the big data and analytics come in. And you probably hear in your own organization you want big data, analytics, data lakes, etc. With the third dimension, the processes, it's patient centricity. It basically, the Boston Consulting Group was talking about customer centricity, but in life sciences, patients come first. So we could think of it as patient centricity, and look at the things that we already know about, like continuous process verification, process analytical technologies, always continuous process improvement. And given the global warming, the dilemmas we're facing right now, it's extremely important to look at how we can make our processes sustainable green production. And then, like I said before, for our industry, we can think of quality as the fourth dimension, and technology in the Industrial Revolution, in the factory of the future, really is beneficial for quality in areas like the computer systems validation with artificial intelligence, predictive analytics. We hear about the maturity model. So you can have, when it comes to technology, the maturity model can be reactive, proactive, predictive, and prescriptive. And in our industry, everybody's pretty much floating around the reactive, proactive. That's not good. If you're reactive, that's not a good place at all to be in. If you're reactive, proactive, you're kind of moving forward, but you need to move a little bit faster. If you're proactive, predictive, that's good. And then if you're predictive, prescriptive, when you're getting into prescriptive, you're getting into really advanced technologies and prescribing. You're predicting a problem and prescribing what should be done about that. And when you apply that to quality, you could think of a production line, and if you have these devices that are all talking together, robots processing information, autonomous devices connected through Internet of Things with RFID and Bluetooth and all, Wi-Fi, all these things, these robots and devices are communicating with each other and telling each other what their operating parameters are. And if they start to predict a problem, they could start communicating, hey, I'm having a problem. Then you may down the production line experience some difficulties because I'm having a problem right now upstream, or downstream they can start getting ready to prepare for something and not only predict that a problem is going to happen, but prescribe exactly what needs to be done to fix the problem, mitigate the problem, or whatever the case may be. So you can see how all of these technologies are coming together in the factory of the future and are promising to us. Now back to the fourth industrial revolution. Again, it's cyber-physical. So we've already talked about robots, autonomy, Internet of Things, devices, augmented reality, artificial intelligence, all that stuff. So that is happening in the fourth industrial revolution. And when we think of artificial intelligence, it's a huge umbrella, and it's made up of a bunch of different things. Inside of artificial intelligence, you have these major components like machine learning, where algorithms are learning. They're looking at the data and becoming better and better at learning the curves, the linearity of the data to predict, shifts in the information, identify patterns. That is part of artificial intelligence. Machine learning is part of artificial intelligence. And then there's natural language processing. If you have Alexa devices or all kinds of things do natural language processing. So speech to text, everything. We can understand languages, even translation services. So that is the natural language processing, and we're getting better and better and better at that. If you compare the way that technology spoke to us not too long ago as very robotic, and now it's lifelike, and that's all handled with NLP, natural language processing. And we can say something and have it automatically translate into a different language. Then you get other things like expert systems, vision, speech, planning, and robotics. Now, underneath all of these things, there's even a deeper level. So if we took machine learning, there's deep learning, supervised learning, and unsupervised learning. If we took natural language processing, we have things like the classification, machine translation, questions and answers, text generations. And then when we look at vision, we have image recognition, machine vision, etc. And image recognition, for example, in a factory of the future, is that I can see if a product is not meeting spec or looks defective in some way. Vision, I could recognize parts. I could recognize all different things. You've probably seen videos where they're sorting out waste and identifying what's paper, plastic, etc. for recyclables. That's an example artificial intelligence. And then when it comes to speech, we can do speech to text or even text to speech. We can type in something and it could say it, or we can say something and it'll turn it to speech or text, and it gets better and better. And then, of course, planning, predictive planning, etc., is a part of artificial intelligence, as well as robotics. Let's take a moment to talk about augmented reality, virtual reality, and mixed reality. With augmented reality, we alluded to this a little bit earlier, where augmented reality is reality first, digital second. And that is safer. So in a manufacturing area, GMP floor, for example, augmented reality is going to put reality first and then digital second. You are augmenting the reality, but you're seeing reality first, and you're providing additional digital information in front of you. So if I go up to an instrument, I can maybe see the maintenance history or the operating parameters of that instrument or that piece of equipment, but I am seeing everything around me, so I'm not fully immersed in a technology, and I can see a problem so I don't trip over something. I don't know if you've had the chance to put on a virtual reality headset, but in virtual reality, you are not seeing anything except the virtual world, and that could be dangerous if you're in a manufacturing environment. Now, when we get to the virtual reality, it's the opposite. It's digital first, reality second. You are immersed completely in that digital world. And it has good, video games, etc., are completely immersive, and they're great. They simulate that virtual world, and training is another great example. You're training to do something. You could literally be taking out the actions and acting like you're doing something in a production environment, but you're not, because you're in a virtual world. But it's totally immersive, so it feels real. There's even tactical feedback to where you get things that can vibrate or simulate different things, so you can it tricks your system into thinking that you're touching something physical, if you will. And then mixed reality is the best of both worlds. So you don't have to decide augmented or virtual. Should I do virtual or augmented? There's mixed reality, which brings both of these things together, and you can figure out what is the best technology to use in a given scenario. So this is an example of cyber-physical devices. I have a physical headset that I'm putting on, and cyber is that software that is operating, that's creating these realities, whether they be augmented, virtual, or mixed. The fourth industrial revolution is bringing together cyber, which is the software digital world, to physical, which is the hardware, mechanical, electrical world. And that is essentially what the fourth industrial revolution is all about. When it comes to the physical, there's no better way to think of it than with robots. And back in 2020, not too long ago, but things move extremely fast. From a source, robots.net, they talked about the different types of robots that we have. And when we think of robots, we jump to what we typically think of as robots, and we see them moving around, maybe from science fiction movies, R2-D2, C-3PO, etc., where C-3PO was really a humanoid, not necessarily the true robot like R2-D2, but you could see that as well. I'll get to that in a second. But there's different types of robots. We send robots to Mars. So the Mars rover is an example of that. And then we have consumer robots like the vacuums and Alexa devices and autonomous delivery. We maybe in our own area, we can see that pizzas are being delivered, and it's promising. So in the future, we may be able to actually have Amazon deliver our stuff to us wherever we may be. So that is an example of the different types of robots as it relates to consumer robots. And then there's disaster robots. We can go in and find people in a disaster. We can defuse bombs, etc. Drones are very promising. They can deliver medications, even in clinical trials. they can perform delivery, especially in hard to reach areas or in emergency situations. And in the military, they use drones where they could actually come out and begin to assess people that may have injuries, and maybe that will become something of an ambulance in the future. A drone shows up first and starts taking your vitals and looking at it before the ambulance actually arrives, so you already know what to expect. We, of course, have educational robots, entertainment robots, and then there's exoskeletons. I just saw a really great thing on LinkedIn where this father was a robot engineer, and he developed an exoskeleton for his son who's paralyzed, so now his son can actually walk around and have mobility. And again, when we think of robots, we typically think of something like C-3PO, and that's more of like a humanoid walking around. And they're really becoming fascinating. Boston Scientific robots are just unbelievable. They can jump off things, do flips, and go industrial robots that can perform 365, 24/7 in extreme cold, extreme heat conditions. And when you think of it, they're kind of expensive in one way, hundreds of thousands of dollars. But if they could work around the clock 7 days a week, then performing certain tasks that may be too dangerous for humans, then that may be a viable solution. Medical robots, we have surgical robots. There was even a warning coming out from FDA warning about the use of surgical robots. So again, it's an example of the technology advancing faster than the ethics, and so we have to be very careful about the use of our technologies. And then military security robots, you may have seen things like police. Maybe the security guard at your facility in the future will be a robot instead of a human being. And then research bots and self-driving car robots, telepresence robots, underwater robots. There's all these different types of robots. So when we think of robots, we can't just think of a C-3PO type of thing. There are robots that are robotic process automation. And in fact, those are very promising. Back at Automation Edge was talking about this in one of their articles, and they had predicted the growth of robotic process automation. Again, these are software robots and automating them, performing tasks that may be routine and mundane to human beings, but they're necessary. They have to be performed, so robotic process automation can be leveraged. And AutomationEdge.com, the CIO guide for robotic process automation evaluation, mentioned that 63% of the work has the potential for workplace automation. So that's 63% of the work that we're doing has potentials to be automated and performed using robotic process automation technology. And the industry is expected to grow by 1.2 billion in 2021. That's right now, with a growth rate of 36%. And we could see it more and more. So you have chat bots on your website. You come in and you ask a question. It could book appointments for you. It could respond, find answers for you, get in touch with the right people, solve problems. These are examples of robotic process automation. Another component of the Industry 4.0, Pharma 4.0, making all of this stuff happen. So how can things be autonomous? How can they communicate with each other? How can we keep track of everything, measuring everything, gathering data about everything so we can make predictions and decisions about stuff? Well, the way to do that is the Internet of Things. Everything is interconnected, so devices talking to devices. We have Bluetooth thermometers. I literally bought a microwave oven that's connected to my Alexa device, and I thought, well, that's kind of gimmicky, but I really like it because I can turn the microwave on and off, and I don't have to push buttons, and I don't like fingerprints on things. So I like it because I can even shut the microwave off. If the popcorn stopped popping, and rather than jumping up and running over and shutting it off, I can just tell Alexa to shut off the microwave. So it's actually more useful than I thought it would be, and it's something as who would have thought? I remember when microwaves first came out. I'm dating myself, but when the microwave oven came out, we were amazed at how fast it was able to cook things, and now we have it to where I can use my voice to control it through an Alexa device. So the the use of IoT, Internet of Things devices is exploding. And if you look over the course of time, Cisco Internet Business Solutions Group, the IBSG, laid out this graph that showed from 2003 to 2020 the growth of the Internet of Thing devices, everything that's connected to the Internet in comparison to human beings. So the world population in 2003 was 6.3 billion. The internet-connected devices was 0.5 billion, and internet-connected devices per person were 0.08. So we had far more people and not a lot of use, 0.5 and 0.8 of internet-connected devices and people, internet-connected devices per person. But things started to change. In 2010, the population was 6.8. Internet-connected devices 12.5, about double, right? And then every person had about 1.84, almost 2 internet connected devices per person. 2015 really exploded. 7.2 billion people, 25 billion devices, internet connected devices, and every person on average had about 3.47 devices. Every human being on average had about 3.47 devices connected to the internet. Now it's ridiculous. 2020, 7.6 billion people on this earth. The internet connected devices is 50 billion. And the internet connected devices per person is 6.58 billion. Every person has about 6.5 internet connected devices with them. And you have your smartphone, you have your watch, you have everything's connected to the to the internet. And you can see that the adoption and use of technology is becoming more and more acceptable, and it's growing. So why not apply that to the Industrial Revolution and in Pharma 4.0 and use all of these technologies to our benefit, provided it's safe and ethical use of the technology. So we always have to be mindful of that. And then even moving out into the future, we have edge computing. You've probably heard of blockchain, not to be confused with cryptocurrency, but the blockchain technology, which Bitcoin uses. So Bitcoin uses blockchain technology, but blockchain is very promising in many different ways because it's immutable. You can't change that blockchain, which gives you assurance that the data is correct and the transactions, etc., are valid. And even with things such as Ethereum, you have smart contracts. So in the supply chain, you could have these smart contracts that is logic inside of the blockchain that is moving things around, informing people. It's basically a task, performing tasks inside of the blockchain based upon a contract. So you can take your handwritten contract and put it into smart contracts in the blockchain, and you can make sure that people are contractually complying with what is required in a supply chain. And blockchain can help with that, as well as data privacy and even things such as audit trails with the immutability. You can't alter data in an audit trail if it's on a blockchain because it's immutable. And if you break the chain, you'll know exactly where it's broken, and the whole thing is broken. Then we move into edge computing, which is even more promising because edge computing, I was talking about the Internet of Thing devices, everything connected to the internet. And we have cloud-based technologies right now. Consider this. We used to have computers at a facility in a server room, as an example. Then that was on-prem servers. Then we started having virtual servers, which scared everybody, but now everybody got used to virtual servers because they could scale and they're dynamic, and that became okay. Need more servers? Just there are more virtual servers. Need more storage? More virtual storage. It was scalable. And need less? You could shrink it down as well. Then we moved into cloud computing. So everything's out there in the cloud. What's the cloud? Well, the cloud is a huge data center that has all these virtual servers with all of this stuff at diverse geographic location, dispersed geographic locations all over the world. So if we have a problem somewhere, that it will fail over to another. So we don't have to worry about a catastrophe at a location that wipes out our data center, because we have many data centers all over the world, and if one catastrophe happens, then it'll automatically fail over to another. So that's cloud computing. And now the future, the next wave, is edge computing. It's on the edge of the cloud. It's all of these internet connected devices. And when you think about the processing power of these devices that we have, the smartphone is far more powerful than what the first computer was by far. There's even no comparison. And we hold these things in our hand, whereas the first computer filled up a room. And so why not use that processing power of everything connected? It's unlimited processing power, if you will, that's connected to the internet, and that's what edge computing is about. Couple that with blockchain, and now I can spread my data all over the place. Okay, that sounds scary, but the way to think about it is, if I had $1 million and I put it in the bank and the bank got robbed, well, it's FDIC insured, so you can get $100,000 back, but you lose all the rest. You lose, $900,000. But if I had edge computing, the theory of edge computing applied to my banking, then I would have $1 million spread out all over the world. So it's not even advantageous. People can't even find it. And what are they going to do? Go around and pick up dollar bills all over the world? So the same thing is true with your data. If you have your data everywhere, all over, and a piece of data doesn't make sense by itself, especially if it's encrypted like it would be on the blockchain. And the blockchain knows where all of that is, but only you would know, because that is your encrypted information, all secured by keys and such. Then you would be able to store everything everywhere, and nobody would know about it. And you can give privileges. You can say, okay, you can take a look at my medical information, and I will revoke access. And we've heard of GDPR and the right to revoke access, even the right to erasure, and it's a challenge for technology. How are we going to erase all that? That information's in databases and backups and spread out all over, so it's a big challenge for us. But if we employed things like blockchain technology, then a person could simply revoke access, and then you no longer have access to their data. People are in complete control of their data by using these technologies. The key points with the blockchain is it's immutable. Like I said before, you can't change it. It's distributed. It's not one place, and there's consensus. So more people are agreeing upon it, and you can only say that this is valid when you achieve consensus on the blockchain. And there's a whole bunch of consensus algorithms and a whole bunch of stuff you can dive into. But even that's changing, where you're getting into ledgers, and not necessarily distributed, but private ledgers and such. So these technologies are evolving and becoming more and more useful to us as we proceed forward. So what's the future? Well, we don't really know. It's gray, but if we take a quick look at history, it's fascinating. And there's a book, Turing's Man, and it talks about we look at and define ourselves based upon the prevailing technologies, the defining technologies at that point in time. For example, the steam engine. We said human beings are like the steam engine. You give us coal, we're fuel, we work. And then you think about technology, computers. People are like computers. Our brains are electric. They think like computers. And so we always define ourselves based upon the defining technologies at that time, and it's always been the case. If you go back to 5000 BC, the defining technology, believe it or not, was the drop spindle. That was amazing. It was like magic. You can do so much stuff with this block spindle that you couldn't do before. And then we get to the potter's wheel in 3129 BC. That was unbelievable what you could do with the potter's wheel. You could start making vases and all kinds of things that were extremely difficult, and they were beautiful. It just surpassed everything. And when you think of how human beings thought of themselves back then with the drop spindle, that was at the time the Daughters of Destiny was conceive the mythology of all that. We're like the daughters of destiny hanging on strings, and there is a puppet master, a godlike figure that is controlling everything. And then the potter's wheel, we are like formed out of clay. And so we can see how we define ourselves based upon the defining technologies. Then we had 1698, the steam engine, 1830, the automatic digital computer. What's fascinating is the term computer is actually human beings. A person would get hired as a computer. They would compute things, and they were a computer. And so I think that's kind of interesting. If we still had people computing everything, we would have to employ all of the people in the world to do a fraction of the calculations that the technology is happening right now. And then in 1943, we had the ENIAC, the first computer. So think about it. Look at all of these things that have happened, and look at the technologies. And so where we're at right now, it's exciting because we are in the middle of the fourth revolution, industrial revolution, just like it would have been for people in the middle of the first one when steam happened and changed the industrial world altogether. So we are at exciting times right now. There's much, much more to it. Of course, we have to always look at the risk-benefit for all of these technologies. We have to see how they can apply. But hopefully you've gotten some insight into what Pharma 4.0 is. It's leveraging all of these technologies ethically, appropriately to advance our companies, to advance our abilities, to advance medicine, etc. And Industry 4.0 is the general term for the fourth industrial revolution, but Pharma 4.0 is focused on the pharmaceutical life sciences industry. We hope you really enjoyed this. It's always interesting, fascinating to learn. If you missed the first podcast, that's okay. That was really our first episode on why listen to the Quality Culture Podcast. It was our official launch and intro show. And the next one is all the hype about computer software assurance. That's another revolution. It's changing the computer system validation mindset, not necessarily changing how we do computer system validation, but raising awareness on how we can do computer software assurance so we could leverage things like least burdensome approaches and risk-based validation and really apply critical thinking. So same day next week, September the 21st, come back and tune into us, and you can listen to What's All the Hype about computer software assurance, a dive, general overview basically of computer software assurance. And then towards the end of the month, we'll be talking about blockchain in more detail and how it will impact the future and how we can understand the potential of blockchain. That's at the end of the month. This is just a start. We just started about the Industrial Revolution. We'll be diving into each of these technologies in more detail, and we want to bring that information to you, and not just a technology dump of information, but an awareness of the technology and how we can use the technology in our industry, and always with a focus on quality in mind so that we are compliant, it's good technology, it's safe, it's effective. Thank you for listening in, and join us next week for What's All the Hype about CSA.